Hello everyone, welcome to our 14th video in the Python for Artificial Intelligence and Machine Learning series. My name is Dheerajchoudhary and today we will expand on our function knowledge by exploring advanced concepts related to return values, variable scope, and different ways to pass arguments to functions. These concepts are crucial for writing more flexible and powerful functions in your AI and ML projects. So let's explore return values in more depth. So function can return various types of data, single values, multiple values as a tuples, collection like list or dictionaries, and even other functions itself as a return value. So if the function has no return statement or an empty return, it will implicitly return none. If a function has no if the return statement immediately exits the function, which is useful for creating early exist based on conditions. So condition returns allows your function to return different results based on input values. In machine learning, you might have a function that returns different model configuration based on datasets characteristic, or a function that returns different evaluation matrices depending on the model type. So we have already seen this in our previous tutorial, but let's have a refresher about the return values in function. So if I go over here, so we by using function, how we can first we can return a single value. So if I run this function over here, we are returning a single value as part of this function that we have defined, which is returning a square of whatever argument that we are passing over here. Then the second one is, as we saw, the way we have returned a single value, we can also return multiple values. So when you have to return multiple values, this is how you can return it. But when you return multiple values, okay, so multiple values are being returned as a tuple, and once you are receiving a tuple, you should also unpack the return tuple. So to unpack the return tuple, as we saw in our last video, how we can do that, we can define our variables in which we want to do the unpacking, and we call the function over here, and along with that we are passing the numbers, that is our argument over here, that is a list, and based on that it is going ahead and providing us the minimum, maximum, and average of the numbers in the list. So if I go ahead and run this, you can see minimum number from the list that was provided was 1, maximum was 5, and average of all of the number is 3.0. Now another thing that we saw that uh, we can also return the values based on some specific condition. So over here I have used two conditions. So one is greater than, one is less than, and the third one is else. So if I am going to go ahead and pass a parameter, that is an argument, so that argument, if it is a positive number, it is going to return positive, negative number negative, and if it is blank, it is going to return 0. So right now I have added a positive number over here, and if I run this, you can see it is saying positive. Now let's go back to our slide. So let's understand the variable scope in detail. So usually variable scope determine where in your code a variable can be accessed. So Python follows the LEGB rule for resolving variable names. It first check the local scope, that is the current function, then the enclosing function, then the global scope, that is the module level, and finally the built-in names that is there in Python. So variables are defined inside a function, are local by default, and only exist during the function execution. As soon as the function is executed, that variable is being deleted automatically. So they are created when the function is called and destroyed when it is returned. Those are the local variables. And variable defined outside all the functions is known as global ones, and they are accessible throughout the module. So that means you can use that global variable in any of the functions that you want. And if you define a local variable with the same name as global variable, the local variable uh, inside a function is going to be created as a uh, the variable, for example, if I create a variable named xyz, which is a global variable on the global level, then I go ahead and define a function. The function name is sum of numbers, and inside that, if I create again xyz, it is not going to refer immediately to the global one. It is going to create a default a local variable inside the new function that I have created. And understanding the scope is crucial for avoiding unintended side effect in large machine learning projects where many functions might use similar variable names. So it's very important for you guys to remember this LEGB hierarchy based on which the variable scope is defined by Python. Now, let's understand the global and non-local variables. Uh, so, global and non-local variable over here that we see, global we have already seen. If you see on the example on the left hand side, x is equal to 10. I have defined this global, it is not inside any function. And when I go ahead and define a function where I say define modify, inside that, if I have to modify this global variable, I have to use a global keyword. So that is how you use a global keyword to modify the global variable that you have declared. Now, the second one is non-local variables. So for non-local variables, what we do, we use the non-local key to access and modify variables in enclosing functions. What we mean by that? So I have right now defined over here two functions that you see. The first one is the outer function and the second one is the inner function, which is inside the outer function. Now, when I say non-local x, what does that mean? That means that the inner function is not going to create a local variable. Instead, it will go one loop outside it, okay, and it is going to get this x is equal to 10 as a variable, and it is going to use it inside this variable. So that's what it says, that enclosing function. So the enclosing function where you have with the inner function where you have defined the keyword non-local is going to refer to the enclosing function, and over here the enclosing function is outer, where it is going to take the value of x is equal to 10. Now uh, let's understand this with example. So I have two examples, one is for global and one is for local. So for global, what we have done is we have defined a global variable over here, counter is equal to 0. Then I have defined a, a, a function. So the function name is increment. So when I am going to go ahead and run this, it is going to increment the value. So you will see that the value which is outside is getting modified with the help of this function, because we are using the global keyword over here, because of which it is actually modifying the global variable over here. Now the second function is for non-local example, that is the nested functions. So as I showed you, so this is the outer function and this is the nested function inside it, which is the inner function. So what I am doing over here is I am saying non-local x, where this x is not going to create a new one, it is going to access this x value, that is 10, and it is going to be 10 plus 5, and it is going to return us the value. So if I go ahead and run this, you will see it has returned us 15, because it has taken the value of x from here and it has returned that to us, and that is how we have printed the value over here. Now what's next? So now we are going to talk about variable length arguments, that is asterisk arguments. So this argument is often referred to as args, as you see over here, and it allows function to accept any number of positional argument. This creates a high flexible function that can work with varying inputs. So in function definition, the asterisk that you see before this argument name makes it collect all the remaining positional argument into a tuple. You can use arguments alongside regular parameters also, but required default parameters must come first before the arguments keyword that you are going to define over there. So this pattern is useful when the number of inputs is unknown and you want to accept as much as number as possible, whatever is been defined. So let's understand this by example. But before going towards the arguments, asterisk arguments, first let's refresh what are the different types of arguments that positional parameters that we can define. So in our last video, we saw how we can go ahead and define a positional parameters and then call it with a positional argument. So over here, we are defining a positional parameters as part of create profile, where we are giving name, age, and occupation. Okay, and it is going to return these values. So what we are going to do is we are going to call that function and we are providing the values for those parameters which are defined over here as arguments, and based on that it is going to go ahead and print the results for us. This is how you can see the results are over here. That's what we saw. Now, we also saw how we can use the keyword argument. So positional argument has to be aligned with the parameters which are defined during the function. So over here, if I say name, it has to align with the name. Age, it has to align with the age. But to avoid this and provide values based on your convenience, not in a synchronized manner, what you can do is you can use keyword arguments. What keyword argument does is you can actually define the values in a shuffled order. So right now, first I am saying name is equal to Bob. I can use name is equal to Bob first also, last also. It does not matter because I am using keyword argument. So it is going to understand the value of the argument based on the keyword that I am passing. That is how you define the keyword argument, and this is how you see the result. So over here, we have actually crisscrossed the order of age and occupation, and over here you can see, but still it is giving the exact output that we are expecting. Now let's talk about the default arguments. So suppose when you are defining a function, during the defining the function, along with the parameters, also you can go ahead and provide some default arguments. So when somebody is going ahead and calling a function without providing any values for those arguments, it will automatically take the default arguments, as you can see over here. So greetings and punctuation is a default argument. Now if somebody is not giving the value, it is going to take the default argument. If somebody is going to go ahead and give the value, it is going to go ahead and override that. Okay, so over here, see, I have given only name at the first print. So it has used Alice from here, hello, Alice from here, and it has taken the default value hello from the default argument and the punctuation. Then second time I have added Bob and hi, where I have overridden the greeting. And third time I have given the name and I have changed the punctuation by using the keyword arguments over here. So that is how you can do it. Now coming to our current concept of asterisk arguments. So over here, what I'm doing is this function accepts any number of numeric arguments using asterisk numbers, which collects them into a tuple. Inside the function, you can see some number adds all the values and length numbers gives the count. So the function returns the average by dividing the sum by the count, as you can see over here. Okay. Now, sum numbers, it is going to give the number of sum of all the numbers, and this is going to give the length, and we are going to divide it and calculate the average. So if I go ahead and run this, you can see the calculated average for the first 1, 2, 3 is 2.0, and the calculated average for the next list of numbers that you have provided is 30.0. Now let's see another example. So over here, what we are doing is this function takes two fixed argument. I told you, right, when you can also club this with other arguments. So over here, what I'm doing is I am actually going ahead and using a default I am using a positional argument over here that is known as fixed argument also. So I am using two fixed argument, okay, that is positional argument, and along with that again I am using asterisk hobbies. Okay, so the hobbies are combined into a string using join over here. So whatever hobbies you define, what we are doing is we are combining all of them by using a join over here. So if hobbies are there and if no hobbies we are going to pass, by default it is going to return a none using a conditional expression that you can see we have used if and else as part of the hobby list that we are defining. So if I go ahead and run this, you can see first time when it ran, I have given the hobbies. Okay, when I gave the hobbies as part of this hobby list, what it has done, it has joined all the hobbies based on the commas that I have provided over here, and you can see it has joined all the hobbies and it has separated them by using commas and a space, as I have mentioned over here. So these are the hobbies: reading, hiking, and photography. These are over here. Now second time when I call the function that is describe person, I am not passing the hobby. So in that case, it is going ahead and returning hobbies as none. That is a none object. So that is how you can use this argument over here. Now let's understand the way we used those arguments. Now we are going to use keyword argument. So when you are going to use, so you can use two different ways. One is variable length keyword argument, and the other one is variable length arguments. Okay, so this is specifically the keyword argument, and how you are going to define those keyword argument is double asterisk keyword kw arguments. So it is denoted by this format, and the double asterisk before a parameter name collects all extra keywords arguments into a dictionary. This creates extremely flexible function that can handle arbitrary settings. You can combine keyword arguments with regular parameters, default parameters, and arguments as well, but they must appear in the specific order in the function definition that we will see. And this pattern is particularly useful for configuration functions or wrappers that pass arguments to other functions. Let's understand this with an example. So uh, our first example, what we see over here is, so this is a function which uses asterisk asterisk user underscore data, which collects any number of keyword arguments into a dictionary. Inside the function, what we are doing, we are going ahead and printing the dictionary and returning it. So as you come inside it, so the dictionary that we are accepting, it is going ahead and printing it for us. Okay, and when we call the create user function over here, we pass multiple key value pairs like name, age, and email, as you can see over here: name, age, email, occupation, and country. And Python packs them into a dictionary and passes it to the function. So if I go ahead and run this, see, so Python goes ahead and passes it as a function, and it is going ahead and printing that value, that is creating user with the specific data that we have passed as our key value pairs over here. This is how you can use multiple keyword arguments. Now let's I was talking about the hierarchy. Now let's see how you can combine it with other ones that we have already seen, that is positional, default, all those. So what in the second example we are doing, so in second example, this functions demonstrate four types of parameters in one place. First is the required, that is the positional argument, that's why I have kept it as required. Second one is optional, that means it is having a default value. Third one is asterisk arguments, which is going to collect extra positional arguments for us into a tuple. And after that, we are using the last one, that is double asterisk keyword arguments, which is going to collect extra keyword arguments into a dictionary. So remember, we saw two concepts today. One was asterisk arguments. What it does, it collects the extra positional arguments into a tuple, and double asterisk keyword arguments collects keyword arguments into a dictionary. There is a difference. One collects in tuple, another one collects in dictionary. And when I go ahead and call process data with the required value, custom optional as 123, key over here as you see, key 123, key 1 is equal to value 1, key 2 is equal to value 2, then what it does is it will go ahead and provide us the following output, where it is printing all the values for us one by one. So whatever values I am passing over here, what it is saying, for the required, that is the positional argument, I have given this value. Now for the optional one, I have overridden the default value with the custom optional one. Now for args, I am accepting multiple arguments, see 1 2 3. So this 1 2 3 has been written as a tuple, that's why it is in parentheses. And the last one, that is key value pair that we are passing, it has been returned as a dictionary. So this is how you can use this accordingly in your code. So argument unpacking is the inverse of arguments and keyword arguments that we have seen before. While arguments and keyword arguments, as we saw, collect multiple arguments into a single container, unpacking spreads a container into a separate arguments. So when you're using unpacking, the way we were collecting, now by using unpacking, we are going to distribute it. So the operator unpacks the iterables like list or tuples into a positional argument, as you can see on the left hand side. So when you have to, you can iterate through the entire list or tuples, and by using asterisk operator, you can separate that into arguments. So this is incredibly useful for forwarding arguments to other functions, building arguments dynamically, or converting between argument types. What we mean by that? So for example, suppose if I am going ahead and passing uh, the positional arguments as well as the keyword arguments, I can take that as an input for a function. I can pass that as an input to another function and return the value of that another function from the current function. I will explain you by once we go to the code. So over here we are in the code. So let's see. First, we are going to unpack a list into a positional argument. So right now what we are going to do is we are going to use star for that. So, okay. So for that, what I have done is I have written a function named sum underscore 3, which is having three positional arguments a, b, and c, and values is equal to 1 to 3, which is a list. So this function is having three positional arguments, and it is going to return the sum of these three positional arguments that I am going to pass. Now, the values that I am going to pass as part of this function that I have written over here, it is having the values of 1, 2, and 3. So when I go ahead and say print sum underscore 3, we call the star operator, which unpacks the list, turning it into sum underscore 3, and it is going to assign the value of 1 to A, 2 to B, and 3 to C. This is how it is going to unpack the values for us, and it is going to pass that in the function, and based on that we are going to get the value returned. So the unpacking is happening over here because we have used star. So this is going to unpack the list and pass the positional arguments to the function. So if I go ahead and run this, it has given 6 because A, that is 1, plus B, that is 2, plus C, that is 3, is equal to 6. That is how you can unpack and you can send that as a positional argument. Now, next example. So over here we are going to unpack a dictionary. Previously we unpacked a list. Now it's time for dictionary. When you have to unpack a dictionary, this time we are going to use double asterisk. So what I have done, I have created a function named create underscore person, which is having three keyword arguments, that is name, age, and occupation. And the person underscore data that you see over here, this is a dictionary that I have created, okay, with the key value pairs. When we call create underscore person asterisk asterisk person data, the asterisk asterisk operator unpacks the dictionary that we have given in person data into create underscore person, and it is aligning the values of this keyword to the arguments over here. So now name will become Alice, age will become 28, and occupation will become data scientist. This actually lets you pass the data stored in a dictionary directly into a function expecting keyword arguments. So over here, our function is expecting keyword argument, and right now we are providing the values accordingly. So if I go ahead and run this function, and if I am able to pass the values properly to name, age, and occupation, it should go ahead and say Alice is 28 years old and works as a data scientist. So if I go ahead and run this code, you can see, yes, the values has been passed accordingly. So it was unpacked successfully from the dictionary, and it was assigned to the create person parameters by sending it as an argument, and you can see the value has been printed over here. Now, what you can do is, if you want to take some arguments, that is with single asterisk arguments that we saw last time and double asterisk keyword arguments, you can collect multiple of them, and what you can do is you can also pass that values to other function. So over here we have taken values from one place, and then in return we are saying train underscore model, and we are passing the same values over here. So within one function I am calling the other function, and when that other function is going to execute with those values that I have passed, I am returning that value as part of this function. That is the meaning of that. And this is commonly used in wrappers, decorators, or middleware, where you want to add behavior before and after calling the real function without changing its interface. So let's see the Python's official documentation. If I go to the official documentation, here it is. So as part of this official documentation, you can see the comprehensive information about function arguments and the return values. The more on defining function sections over here, more on defining is going to cover default arguments, keyword arguments, special parameters, everything. So you can go through it and you can have a better understanding if you need more examples or want to perform more hands-on. So thanks everyone for your time and participation. I encourage you to experiment with the concepts we discussed today. If you have any questions or thought, feel free to drop them in the comments below and I would love to hear from you. Remember, programming skill improves with practice, so try to apply these concepts in different contexts to solidify your understanding. Join our WhatsApp community, subscribe to our YouTube channel, and sign up for Tech Insight Neuron newsletter. The links are displayed on the screen as well as in the comments and the description below. So see you in the next video. Take care and bye for now.